Hello and a very warm welcome for today's webinar. We are the EECONE project and we are all about reducing e-waste through innovation and collaboration. My name is Moritz Schlagmann and I'm very happy to be your host for the session. And I want to welcome you all on the behalf of the EECONE project. So we have two interesting topics, but first I will briefly introduce the project to you again maybe, and then we will go over to the presentation of my colleagues, and at the end we will have the Q&A session. So we are EECONE, the e-waste reduction project, and we want to develop a technology for a zero waste future of electronic components and systems. And we are guided by the 6R principles: reduce, reliability, repair, reuse, refurbish, and recycle if nothing else is left. And we have our 4 key objectives. First of all, we want to define green ECS because sometimes it's not clear what is green, where can we improve, and what needs to be done. Therefore, we want to create a clear, simple, and open tools to define this. Then next step is we want to make green ECS, green electronic components and systems. This are we doing by providing innovative techniques and new materials, tools, but also from a holistic point of view to boost the circularity. Then at the end, we also want to showcase green solutions. Therefore, we want to demonstrate in 10 different use cases what we have done. And last but not least, we are to building consciousness. And building consciousness has always to do also something with asking questions. And this will be one part of today's topics where we have a survey-based analysis on how are different partners and collaborators from academia to large industry seeing green ECS and what can we do about it. And who are we? We are the EECONE Consortium. We are over 50 partners from 14 different countries. And today we are focused, we have rather focus on France with ST, but also with the colleagues from ST in Italy, SEA, and INP-GRE. And just to give you an idea of how interactive it is, so we have partners from all over the value chain. So we are starting with material and processes where we support the whole production of the electronic components and systems. Then we have also semiconductor solution providers like ST or Infineon. And this is supported by a big ecosystem of LCA experts, but also eco-design experts, coming then also to our key application, where we are in the domain of aerospace, automotive, medical devices, but also consumer devices, and last but not least, in data centers, where we see a big challenge in the future ahead of us. And also at the end, then the reuse, recycling, and the waste management, where we have big support from our French partner, Recycling. This all is supported also by a data science and data management to collect it and make it visible what we are doing. And today we want to give you insights on our circularity aspects, but also on the 6R principles, how they are applied, where are pain points, what is good, what is bad. And with that, we have two presentations. First, Elise Chaumat, Carolynn Bernier, and Lorenzo Riela have provided and have written a nice white paper about the SWOT analysis of the 6R approaches in electronics. And the second talk is presented by Tugce, Turkbay-Romano, where we analyzed our survey-based responses on how it is actually applied. So this is what is the current status and how can we improve and where can we improve it. And with that, I want to hand over to our first presenter, to Elise.
Hello, everyone. Can you hear me? Yes.
Can you see the screen? Perfect. So thank you very much, Moritz, for the introduction. So I will begin this webinar by presenting the SWOT analysis related to circular economy strategies within the EECONE Consortium towards e-waste reduction that we carried out with Carolynn, Lorenzo, and I, so both CA and ST Italy, during the past 2 years. So as Moritz explained, we wrote a white paper on this. So here the idea is just to provide a short summary of the work, especially the methodology, and also introduce the white paper, but it won't go much into detail of the results. So first, regarding the methodology, it began with a joint survey that we did with INP-GRE regarding the ecosystem understanding survey, so understanding the ecosystem we had in EECONE. And from that survey, on which we had 74 respondents, we selected 16 candidates, out of which 10 actually agreed to be interviewed. And so with Lorenzo and Carolynn, we interviewed them in the past spring to understand everyone's participants' company's strengths, weaknesses, opportunities, and threats regarding the current 6R strategies that they were setting in place. And we really selected those candidates based on the high level of expertise they had on one of the 6R, and also the years of experience that they had on those Rs. We really wanted to have experts on the domain. And we also paid attention to the positions of each company within the electronic market to have good representativity of both size and supply chain position. So here is a summary of the study participant data. So basically we had 4 participants from SMEs, 3 participants from research organization, and 3 from large companies. So we have quite a good representativity in terms of types of organization. We have half of the interviews that were from private sector and 3 from public sector. And we had most people that were actually from research and development. They were mostly researchers, people from quality, also from sustainability management, and from sales, and also for the SMEs, some were actually the SMOs, the CEOs of the SMEs, sorry. And overall, considering the supply chain, we really had the entire supply chain that was represented. So we had people that I called raw material producers, so recyclers, really, then component manufacturers, design house, system manufacturer, and consumer product manufacturer. So these were for the private companies, and also we had people from private sector, so research, both at recycling level and chip design level, and we also had people that worked on eco-design methodology support, so with people from the entire value chain. So we had quite good representativity of the whole value chain, basically, with the experts we selected and interviewed. Just before we get into the overview of the results, quick definition of what we call strengths, weaknesses, opportunities, and threats. So the strengths are companies' current capabilities regarding the 6 Rs. Weaknesses are what are the issues that are currently being addressed by partners. Opportunities are the aspect that could actually be an advantage to companies, and threat are everything that could endanger the ecosystem's effort towards the 6 Rs. So here is just, so everyone has it, is the link to the white paper that was published on Zenodo. The idea of this paper was really to use as much as possible direct quotes from the expert that we interviewed from the EECONE project. The idea was really to directly hear from them like how they're working towards improving circularity, what is challenging, what they're struggling with on a daily basis. Yeah, the idea was really to hear their voice, so we kept as many quotes as possible. And here is a short summary of the main outcomes that we got. So regarding strength, everything regarding material efficiency and energy efficiency are things that, and also reliability, that companies were used to work on. They were already working on that, so they have a strong expertise on this. Many companies are now adopting life cycle assessment to assess the impact of their processes and their products. And also implementing 6R is usually in line with collaborators' personal conviction, so they're actually motivation in the company to go in that direction. In terms of weaknesses, however, for now, more sustainable products are often more expensive, so it's a bit tricky and a bit more tricky for customers to pay for them. There are also the issues of always finding balance between performance, cost, as I said, and more sustainability. Especially for reuse, the aspect of monitoring component health is still an issue and not yet easy to implement for most companies. They also a lot mentioned the lack of transparency along the value chain, especially regarding data exchange for LCA, for instance. This also goes with the lack of collaboration between partners within the value chain, lack of training on circularity topics and standardization. And also regarding recycling, the cost of free material for now remains too low for sometimes recycling to be actually profitable compared to using raw materials. In terms of threat, for now, most identified that there's not enough incentives for companies and from customers to go for more circular and sustainable products. Current technological developments are actually hindering circularity. For instance, technologies there's the diversity of technology is increasing. They're more and more complex, and they're also more and smaller and smaller, which is complex for recycling. There's a lack of actors in the reverse supply chain. And there's also a lack of coordination between designers and recyclers. They don't talk enough together. And finally, in terms of opportunities, because the 6 are bringing new business opportunities, companies that implement them have a competitive advantage, and they're also anticipating the future regulation and also the current regulation. It opens to them new market, new partnerships. It also brings opportunity for new innovation and also for data-enabled circularity. So this is the other all points that were mentioned, and you'll see them more in detail with the quotes from everyone in the white paper. So this is all for this summary, and I leave the floor to Moritz again.
Yeah, thank you very much for the nice introduction of the paper. It is already online on Zenodo. I mean, you should already link. Now it's also in the chat, so please check it out. It's very interesting and worthwhile to read. Thank you. Then I would hand over now to Tugce for our second presentation. The floor is yours.
Thank you, Moritz. So I'm sharing my screen. Okay, can you see my screen?
Perfect.
Okay.
Thank you.
So, hello everyone. I am Tugce Turkbay-Romano, a researcher working on circular electronics at G2 Lab at Grenoble INP in France within the EECONE project. And I will present today a survey-based analysis of circular electronics ecosystem within the EECONE Consortium. So we will try to understand how different organizations understand and apply circular economy strategies in electronics, what are the challenges they face and the opportunities they see. So here is a brief overview of the presentation. I will start with the survey's objective and the method used to collect the data. Then I will present the results and finally finish with a short summary of the main findings. So starting with the research design, the purpose of the survey was to map how the 6R strategies are interpreted and applied across the EECONE consortium, and to identify the key actors, drivers, barriers, and levels of expertise. We also wanted to understand if existing business models are sufficient to support the circularity. And to do that, we first need a common reference for what we mean by the R strategies. And as you can see in the project logo, EECONE is built around 6 R strategies: reduce, reliability, repair, reuse, refurbish, and recycle. So these are the 6 R strategies from our analytical framework for the entire survey. And all of the results you will see in the survey, they are structured around these 6 R strategies. So in terms of the data collection, the survey includes 51 participants from different types of organizations, namely research organizations, large companies, and SMEs. We used a 2-round design for the survey. So the first round in 2024 established the baseline by mapping how the 6 R strategies were understood, applied, and the opportunities. And for the second round in 2025, we focused on clarifying the concepts, especially the R strategies, identifying the barriers, and examining implementation at the product level. So these results are now being prepared for a scientific publication. And so full access to the findings will be available. And here, before moving into the results, there is one important step. We need a shared understanding of what the 6 R strategies mean. And in the survey, we gave several definitions for each R strategies and asked participants how well each one describing the strategy. So the definitions you see in the on the slide, they are the ones they are the ones scored the highest. So they reflect the most common understanding across the ecosystem. And using these definitions means that when we compare how the R strategies are applied, ranked, or valued, we are looking at the same concepts in the survey, not different interpretations. Okay, going to the next slide. And now I will present the survey results. We organized them into the 4 main parts. We start with who the participants are and how they implement the 6 R strategies. We then look at why they do it through the motivation, the perceived impact of the circularity, and future opportunities. And next, we compare which actors are currently involved with who should be involved. And finally, we will examine the main barriers that limit wider adaptation of the 6 R strategies. Okay, let's start with who took part in the survey. We have a mix of public institutions and private organizations, so around 60 to 40%, and that gives us perspectives from both sides of the ecosystem. And that's important because they play different roles, but they are complementary in advancing the circular economy. And going to the next one, we now see the range of organizations in the survey. We have a strong presence of research organizations as well as large companies and SMEs. And in terms of their role in the supply chain, research organizations are mainly active in design and R&D. And on the other hand, the companies are mostly manufacturers, with some SMEs are also involved in design and R&D. So this mixture gives us perspective from both development and production across the electronic value chain. So we continue with the organization types, and this slide shows respondents' expertise. The majority's expertise is clearly by R&D and design profiles. And also we have much smaller contributions from non-technical manufacturing and sustainability roles. So that's meaning that the results mainly reflect how circularity is approached at the design and development level. And while operational and sustainability perspectives are less representative. And also, we do not have it in the presentation, but around 95% of the participants' background are from engineering and scientific background. So also it will impact the perspective from the survey. So the next one is to understand how advanced respondents are in circularity. We ask about their knowledge in several key categories. So they rated their knowledge on circular economy, eco-design, recycling, and visibility of end of life. And the results are grouped by organization type and perceived strengths and their weaknesses. So if we start with the research organization, they feel most confident in circular economy and eco-design, but they clearly identify end-of-life visibility as a weak point. And for the large companies, they show a similar pattern. Eco-design is a strength, while what happens to product after use is much less clear. For SME, eco-design also stands out as a strong area, but they report weaker knowledge in the end-of-life visibility and also circular economy and recycling. So what we can say is that across all the groups, we see the same gap, limited visibility of what happens to product at the end of their life. And this is a critical issue because without that visibility, it is hard to truly close the loop of the circular economy. And even when good eco-design practices we have. So this is the conclusion of that slide. And now we will compare which of the 6R strategies are currently being applied by research organizations, large companies, and SMEs. And the aim is here we are trying to understand how different R strategies are actually distributed across the organizations. And we are trying to understand which parts of the ecosystem are carrying which parts of the circularity in practice. So here, reduce unreliability. It's clear that across all organization types, showing the most efforts focus on design and prevention. And the next one is strategies further down the value chain, reuse, repair, refurbish, are used less overall and vary more between the groups. The last one, recycling, shows a different pattern. It is most prominent among the SME and less common in research organizations and large companies. And overall, we see a clear split here. Traditional sustainability efforts, which are the reduce and reliability, is more prominent. And while more downstream activities are less applied in our within the context of our survey. So now we asked the participants about their level of expertise with respect to each R strategies in electronics. And this radar chart shows how respondents consider themselves skilled in each of the R strategies. And so we will see that where expertise is already strong among those driving circularity and where more skills are needed. So here we start with the expert level knowledge for the each R in the green area. And what stands out is that very few participants identify themselves as expert. And what we see is that highest concentration is in the reliability. So we see that even within an ecosystem actively working on circularity, the technical expertise is limited across the most of the R strategies. And now the next one is the good level of expertise. The picture becomes stronger, and especially for reduce and reliability. And here, many participants feel confident, even if they don't see themselves as experts. And for repair, reuse, and recycle, confidence is more moderate, and refurbish remains the weakest area. And now we see low level of expertise in the purple area. So we see that for many art approaches, especially refurbish and reuse, there is still a significant share of participants who less experience. So while general awareness of circularity is high and also eco-design, we saw it on the previous slide, deeper hands-on knowledge in some of the art strategies is still limited. And our last analysis is the red area represents participants who reported having no personal expertise. And we see that non-level is highest for refurbish, repair, and partly for the reuse. And taken together, this shows that scaling up the 6 Rs, it's not just about developing new technical solutions, but also about we need to consider about building the skills, the capabilities, the training, also the knowledge sharing, and that will be essential to scale up, to strengthen the circularity in practice. And another point we need to consider, limited experience can influence in our survey how participants respond to the questions. And we will see some of the gaps, and it could be because of the lack of expertise and rather than the lack of interest. And in addition, here I want to emphasize that since refurbish seems as the strategy with the lowest knowledge level and also less implemented one by the organizations, we looked at this strategy more closely through the open-ended questions. I will return to these results later when we discuss its main opportunities and barriers. So coming to this slide. So this slide shows at which product scale each of the 6 R strategies is currently implemented. It's from material to the components, ECVs, systems, and finally the end product. So here we see that different Rs operate at different levels. Starting with the reduce. Reduce is mainly at the material level and system level. And recycling is also concentrated at the material level and product level, and where collection and recovery takes place. And by contrast, reliability, repair, and reuse, they are peak at the system level. And also what we see as a pattern here, the less activity appears at the IC, ECV, and component levels for all 6 Rs. So we can say that these intermediate layers are where circularity is hard to implement. So even though they are technically critical for the circularity. So how can we summarize this one? The circular strategies are applied mainly at the material level and system and product level, while middle of the product architecture remains a major bottleneck for circular electronics. So we discussed about the participants' profile and their 6 R implementation. Now we can have a look at what are the motivations for them to implement these strategies and what are their perceived impact and what are the future business opportunities. So first we will start with the motivation. So we see a radar chart, and this figure shows the results of normalized results for the reasons why organizations implement the 6 R strategies. The values represent here we are seeing the relative importance of each driver within each organization type. So what we see is the first, proactivity. Proactivity is strong across all the 3 groups, 3 groups of organization, indicating that many actors frame circularity as a strategic and voluntary choice, and rather than only a response to pressure. And research organizations show the highest emphasis on the proactivity. And when we look at the large companies, for them, requirements from management and from the clients also major drivers. So that highlights the role of internal governance and market expectations. And SME here, they display a different pattern. Economic motivations are the strongest driver for them, which requirements from the clients as a secondary. So it means that adaptation of the 6R strategies is closely tied to financial viability and the business opportunities for SME within our survey ecosystem. And the last one is the legislative. Interestingly, legislation appears less prominent as a direct motivation across all the groups. However, the strong focus on proactivity, it could be because it could be reflecting organizations getting prepared in advance for the future regulations. Okay, these are the motivations for the companies. And a second one, we asked the participants what is the potential impact of the 6R strategies for circularity from their perspective. And we asked them to rank the 6R strategies here. And they ordered them from most to least important by their perceived contribution to circularity. So in this figure, we see how the 6R strategies were ranked by different organization types. Across 3 groups, reduce and reliability, these 2 strategies, are ranked the most important one. And reduce is especially prioritized by the SMEs. And on the other hand, reliability is valued similarly across all organization types. And participants see the strongest leverage for circularity at the design and production stages, we can say. And going to the next one, the other strategies, repair and reuse, they are in the middle of the graphic. And research organizations tend to give them more weight, while SMEs place relatively less importance on the reuse. And refurbish and recycling are ranked lower. SMEs, however, they are assigning more importance to these strategies, refurbish and recycle, than the other groups. And we also saw a similar pattern with SME for the application of our strategies on these strategies. And to sum up, most participants see the biggest impact comes from traditional sustainability efforts, which are the reduce and reliability by designing better the products. And here I want to get your attention that one final points concern the hierarchy of the circular economy strategies. So in the circular economy concept, in general, design decisions have the greatest impact on the circularity. So if you want to make the product circular, increase its circularity, it depends on the decisions are taken during the design phase. So once product is manufactured, the best strategies this time are related to those can recover the functional value from the product. So here, these are the strategies: reuse, repair, and refurbish. And material recovery comes last, since the added functional value of the product is lost. So in this chart, we are seeing that actually we are the potential impact of the 6R strategies taken from the reported from the respondents, actually we are aligned with the circular economy concept. And the last one, in terms of the potential business opportunities for each Rs, we see how participants perceive these opportunities. Across all the groups, reliability, we see that it stands out as the strategy with the strongest and most consistent business potential. And large companies, the blue one, in particular, see reliability as a key source of future value. Also reduce scored relatively high for all organizations. So that indicates expectations of continued opportunities in material efficiency and design optimization. And in this graphic, reuse and repair are seen as having moderate business potential. And SMEs are more optimistic about repair than other groups. And refurbishing receives the lowest expectations overall. And when we look at the recycling, so recycling is seen as having lower impact on circularity by research organization and large companies. On the previous slide, we just saw it. But here we see that it is having almost as much as business potential as reduce. So even though participants think that here it has less potential impact for the circularity, the recycling, here we see that there is the promising business opportunity for that one. So we finish the drivers, the opportunities of our strategies. Now we will discuss about the actors currently involved in the organization of the respondents and which actors are expected to involve to scale up the circularity. So in this diagram, what we see, the solid line, the first one, the solid line, the smaller one, shows who are currently involved in the implementation of circular economy. And today, responsibility is heavily concentrated in R&D and design, and with some involvements from manufacturing. Other functions, such as legal, marketing, sales, they are much less engaged. And however, when we look at who should be involved, the dashed lines, the bigger frame, the picture changed significantly. And respondents call here for much stronger involvement from marketing and sales and the supply chain and logistic, quality, and the legal functions. So in other words, participants clearly see that circularity, it is not just a technical or design issue, but as something that requires coordination across the entire organization. So these are some comments for the actors involved. They should involve. Okay. Now we discuss about the actors, and we can move to other side of the picture. What makes implementation difficult? And now we will discuss about the barriers. To the participants, we ask we predefine some categories of the barriers, and we ask them to rank them between 0 and 5. And here you see the main categories. We group these barriers into the 3 main broad categories. The first one is economic barriers, emerging barriers, and the last one is barriers related to expertise of the respondent. So what we see here is that the strongest barriers are clearly the economic one. So the strongest barrier is the cost. Even when organizations see environmental or strategic value in circular practices, we can say that the high upfront investment, the operating cost, and uncertain returns are still a strong barrier for the companies for the transition to circular economy. And this tells us that even when circular solutions exist, they are not easily adopted because they do not fit, maybe they are not fitting the current cost structures or business models. And in the barriers, when we look at the next group, the emerging barriers, which are the environmental impact assessment skills, legal and regulatory issues, they are more reflecting the transition challenges with circular economy. Regarding the environmental impact, the first one, environmental impact assessment, it refers to the lack of clear, usable ways to measure and compare them. And other emerging barriers here are more related organizational and policy-related obstacles. And that's making it difficult to operationalize the circular strategies at scale. And the last one, when we look at this technology, data, and product performance, it's relatively slower than the other barriers. And from the respondent's perspective, can say that circularity is not mainly blocked by a lack of technology or by poor product quality, but more by economics, business logic, and the ability to measure and justify the environmental impacts. But on the other hand, we need to take into consideration is that the participants in our survey, their background is coming from engineering and science background, and lots of them, the majority is working in R&D and design. So this part is there as their expertise. Also, it could be the reason why these barriers are less support. And in the research paper, actually we detailed all these barriers to the subcategories, and you can see them in more detail in the research paper. So the last one I will talk about. So during the presentation, during the survey results, when we were discussing, we saw that refurbish was less prominent in the responses. And therefore, we asked the participants to describe its main opportunities and barriers in more detail. And here we listed some of the responses. We grouped them. So let me start with the opportunities. Economically, refurbishment, some of the responses, they were saying that refurbishment can lower product costs for customers and open new markets for second life products and support service-based business models. And the secondary, from the environmental perspective, the benefits are clear. So through the refurbishment, we are decreasing the environmental impact of the products. And there's also an innovation angle. Refurbishment encourages more modular and upgradable design, the new product concepts, and the new skills in the circular design. So now we talked about the advantages, the opportunities of the refurbishment. However, these opportunities face strong barriers on the other hand. So technically, many products are not designed for disassembly. This is many times this answer was pronounced by the respondents. And high integration and complexity make refurbishment difficult. And the condition of used components and the product in terms of their state of health, it can be uncertain, or there is the need of technology to measure it. And another barrier category we collected from the answers are trust and certification. So customers question the reliability of the refurbished products, and the problem is that there are no clear standards for requalification of the product to re-put it in the market. And the concerns about the cybersecurity and software support further reduce the confidence. The last one we grouped is the one of business and logistics. They also limit the progress, and the new products are often cheaper than the refurbished ones. So requalification also is costly, all this process. And the biggest problem we collected from the participants is that reverse logistics systems for collecting and used products are weak or missing. So we can say that overall refurbishment has strong economic and environmental potential, but it is constrained by product design, the missing standards, and the technology to measure the state of health, and underdeveloped reverse logistic chains. So these are explaining why the refurbishment remains one of the least adopted 6-star strategies today in our survey ecosystem. So now let me close by bringing the main messages together. On the current situation, we see a clear pattern. Organizations are mainly driven by proactive actions rather than by regulations, even though policy pressure still plays a background role. And the second one is in terms of what is implemented, and reduce reliability clearly was clearly they are prominent, and these are design stage strategies, and they are well fitting with the strong R&D profile of our participants. And by contrast, refurbish is the least applied strategy, and also the one with the biggest knowledge gaps and strong barriers. And we just discussed what are the reasons of that. And for the key knowledge weakness, it is on the end of life visibility. So across organizations, there is a little insights into what happens to products when they leave their control, which makes it difficult to close the loop of the circular economy. And regarding the actor involvement, R&D is highly engaged, but marketing, supply chain, quality, and the legal functions are much less involved. We also see that most of 6R strategies happens at the material and system level and also end product. In contrast, ICs and PCB receives the much less attention. So looking for the future, I didn't present it, but we asked the participants what are the plan of their organizations to scale up the circularity, and lots of answers. They were mentioning about the green gas reduction, decarbonization, and increasing the integration of eco-design and LC in their model. And the last one, in terms of business potential, reliability and repair stands out as the most promising strategies, and also because they are fitting well with the current business model. And refurbish remains more uncertain. That reflects the technical, organizational, and trust barriers we saw earlier. So to summarize, for the transition towards circular economy, we need to leverage the barriers, and we need to take into consideration which actors needs to be involved more, and then we need to focus on where there is the less implementations or high implementation, and then how we can increase them. So thank you for your attention.
Thank you very much for the very nice analysis of our surveys, and I think that gives really a good insight and shows what we can dig out of the surveys and learn more and see where we still have to improve. Now we're coming to our Q&A session. So all the attendees are very welcome to write your message into the chat. So on the bottom right side, there is a chat sign, and you can just type in your messages, and then we can go over it. And I would ask the presenters also to share the camera again. And I would start off maybe with a clarification question towards Tugce. The survey we did, is it only with the participants inside EECONE, or was it a general survey?
So I can start for this question. And for the survey analysis we carried out that I presented, all the participants from the EECONE project. So it is somehow it's representing a small group, and that's the reason also we wrote in the project in the presentation title the perspectives from the EECONE Consortium. So, but we can do extrapolation for all the ecosystem from this our small sample, I say.
Okay, yeah, perfect. Thank you very much. Then I would like to have a view into the future, and want to know from your findings now, what would be your wish if you have unlimited budget, or if you have the resources to do so? What would you change in order to get ahead with sustainability? What are the most interesting fields or technologies would you try to refurbish more, as it is underdeveloped or maybe under specified at the moment? We can go maybe step by step. Tugce, you can start, then Elise, and then Carolynn.
Okay, and especially for the refurbish, what we discussed, there are many opportunities, and at the same time, there are many barriers. And these answers are mainly coming from the engineering background participants. And I can say that I'm sharing many of the barriers and opportunities with them. And what can be done is that the refurbishment strategy, especially, can be incentivized more, and to encourage companies, research organizations to work on this topic, because through the refurbishment, actually, we can extend the lifetime of the product. And so I believe that it is one of the strategies serving the circularity. And for other strategies for the reduce and reliability, what we see is that they are already well installed in the current business model. So might be for these two strategies, it will continue already as it is already dominant. But for other strategies, for example, recycling, there's a high business opportunities, and the collaboration with downstream actors, it could be increased to scale up the circularity. And there are actually, from this survey results, we are getting many points which points, where are the weak points, and where we should focus on, and where we have the opportunities, and where we can go towards. And yeah.
Mm-hmm. Yeah, that's very interesting. Yeah, Elise, what are your points? Where would you go? What are your improvements you want to see?
On my side, I would, because what we got from the interviews from several participants was the problem of we are having more and more complex products. They're changing very fast, always new technologies, and from people that are repairers, for repair. Also for people, if you want to reuse, like you get a system that was from 5 years ago, maybe all the components are obsolete because they're no longer used because it's changing so fast. And same for recyclers. Yeah, so I'd say this is a big problem if we want to talk about circularity, because we're not able to recycle, reuse, because what we get at the end of life is no longer, it's not meaningful to use it because the technology changed. So I'd say standardization for me would be a key aspect to enforce, even if it means limiting, less innovation, less performance sometimes. But I think it might be the price to take if you really want to be more circular. Yeah, for me that would be the key point.
Mm-hmm. Yeah, very interesting. To reduce a bit the speed, or we have to speed up the circularity on the other hand side. But as you said, if it's obsolete, yeah, what can we do?
What can you do? Even recycling the materials, maybe for PCB it's okay. The recycler we had, one was on batteries, so on her side the materials were changing really fast, because we had NMC, now we have LFP, and it's even changing, and so they're not even able to recycle for instance, NMC, the cobalt in it. If we stopped, we would not stop using them, but if we stop using NMCs in the future, then all the cobalt, where do we reuse it in a way? Mm-hmm. And they've developed all this recycling processes, and they're not useful because now we have new technologies of battery, which is LFP.
Mm-hmm.
So yeah,
interesting. Even if you want to close the loop, then you get a loose end at the other side because it's not reused anymore. Interesting. Carolynn, do you have something from your side what you want to add for the future in terms of research and innovation?
Well, I think that the results of this survey are interesting, in particular in the context of the negotiations going on in Europe on the new the revision of the new legislative framework for products, and the EU Product Act, and the new European Circular Economy Act, which are extending what the ESPR, so the Eco Design for Sustainable Products Regulation, started to put in place. And so what we see is that extended producer responsibility schemes are being extended to more and more industries. And I think that this is a good moment for industry, for the semiconductor and electronics industry in general, to make sure that these new legislations, they go in the direction of, yes, more circularity, but also solutions or approaches that are business compatible. And what we see in this survey is that many industries are taking the circular route for business reasons, right? And so it makes sense that industry pushes a direction of these new European legislations that go into the direction of where industry sees value in going. And so I think that this is a good way for the industry as large to take stock of what is their interest and what is their own personal interest, economic interest, but also what is in the more general interest of the population, which is to go towards more circularity. And so you would have, like, hopefully a win-win situation here.
So you see a big driver coming up in terms of economic, but I mean also the social benefit in general. What would be one specific area that you would like to see improve? Is it better production mechanisms, or is it the, let's say, reusability of semiconductors, or? Difficult question, I guess.
It's difficult to answer because there's so many application scenarios if you're talking about, you know, military electronics or aviation or consumer electronics. And so we see reuse happening in extremely, you know, important niche type applications, but where the mass, I think where I would like to go is where consumer electronics, because consumer electronics is the mass of the electronic scale. So, of course, we interviewed people who do fantastic work on chip reuse, technologies and approaches and traceability solutions for that. But those are niche. They remain niche, you know. They're super interesting, but they're niche. And so what we need to address is more the consumer, I believe, in my opinion, the consumer electronics market.
Mm-hmm. Yeah, very interesting. Yeah, I mean, hopefully from the niche you can come to the consumer market and then address the broader part of it.
Ideally, but it's a cost. We're not at all the same cost levels, unfortunately.
Cool. Yeah, thank you very much. I don't see any questions in the chat for now. Did I miss something? Otherwise, we are coming close to the end of the webinar. So I would like to chance to thank our presenters for your nice presentations. You can always find us you can find the webinar also on the webpage. You can reach out to us. We are always happy to help you. And I would also extend a special thanks for Tugce, because she was, let's say, the host in the background of organizing all our webinars and supported us here nicely. And hopefully we can also publish the results of our survey here. So thank you very much. Also, thank you very much to you, Elise, to you, Carolynn, and I hope to see you soon again.
Thank you.
Thank you.
Bye.
Thank you.
Bye-bye.
Bye-bye.